Hi students, today we discuss about the topic view of data. So a database system is a collection of interrelated data and set of programs. So which allow user to access and modify their data. So the main purpose of a database system is to provide users with abstract view of the data. So the system, what it does, it hides certain details of how the data are to be stored and maintained. So data abstraction. So every system should be capable of retrieving the data efficiently. So the need for efficiency has led designers to use complex data structures to represent data in the database. So many database system users are not computer trained. So developers hides the complexity from the users through various levels of abstraction. So it is done to simplify user interaction with the system. So there are three levels of data abstraction: physical level, logical level, and view level. So physical level, which is the lowest level of abstraction, it describes how the data are actually stored. So for example, a record, a student, so how it is stored at physical level. So physical level will describe the complex low level data structures. So next level is logical level. The next higher level of abstraction describes what data are stored in the database and what there is a relationship exists among them. So the implementation of the simple structures at the logical level may involve complex structures. So the users of the logical level does not need to be aware of this complexity. So we refer this term as physical data independence. So next level is the view level, which is the highest level of abstraction, which describes only part of the entire database. Many users of the database need not know all this information. They need to access only the part of the database. So here we have the relationship among three levels of abstractions. So physical level, logical level, and then view level. So view level, we can have more number of view levels. So many high-level languages will support notion of a structured type. So for example, if you take a record, student. So basic details we need is ID, name, department name, etc. So for each field, we require the data type. So the code will have the four fields with their respective data type. For example, in university organizations may have several such record types. So including department, courses, and student. For example, if you take with the department, the respective fields will be department name, building, and budget. And for the course related, we will have the course code, title, department name, and number of credits. And if you take the students, so there we have the field ID, name, so department name, and then total credit he earns. So at the logical level, each record will be described by a type definitions, like the code segment, and there will be an interrelationship between the record types. So the programmers using a programming language work at this level of abstraction, and the database administrator usually works at this level of abstraction similarly. Finally, the computer users sees a set of application programs which hide details of the data types. So at the view level, several views of database are defined, and the database users see some or all of these views. So in addition to hiding the details of the logical level, the views also provide a security mechanisms to prevent users from accessing other parts of the database. So next is instances and schema. So databases changes over time as information is added or deleted. So the collection of information which is stored in a database at a particular point of time or a particular moment, we say that as instance. So overall design of the database is called as database schema. So schema are changed infrequently. So database systems have several schemas partitioned to their levels of abstraction, like physical schema, logical schema. So physical schema, obviously, it describes the database design at the physical level, and the logical schema describes the database design at the logical level. And we have subschemas also. So database may also have several schemas at view level. So logical schema is more important in terms of its effect on its application programs. So the physical schema is hidden beneath the logical schema and can usually be changed easily. So application programs are set to execute physical data independence if they do not depend on the physical schema. Data models. So underlying the structure of the database is the data model. So why we need data model? So data model is a collection of conceptual tools for describing the data relationship, and data semantics, and then its consistency constraints. So data model provide a way to describe the design of the database at physical, logical, and view levels. There are a number of data models we have. So we have classified into major categories under relationship model, entity relation model, object-oriented data model, semi-structured data model, and then other models like network model and hierarchical model. So relationship model uses a collection of tables to represent data and its relationship. So each table will have multiple columns. Each columns will have a unique name, and the tables are known as relations. So the relational model is an example of a record-based model. So each table, for example, it contains records of a particular type, and each record defines a fixed number of fields or attributes. The column or a field or attribute of a particular table corresponds to the attributes of the record type. So relationship model is most widely used data model. And here we have the employee table, which includes his name, ID, and department details. Next is the entity relationship model. Entity relationship model uses a collection of basic objects called entities and relationships among those objects. An entity is a thing or object in the real world that is distinct from other object. And here we have the entity relationship diagram of faculty and then department entity set. So faculty is in one entity, department is another entity. So faculty entity has faculty ID, faculty name, phone number, other details. And department entity has department ID and then department sets. Next is object-oriented model. So object-oriented model, especially we have come across in Java, C++, C#, has become the dominant software development methodology. So this led to the development of object-oriented data models for extending the ER model with encapsulations, methods, and object identity. So this object relation model combines features of the object-oriented data model and relationship model. And next is the semi-structured data model. So semi-structured data model, it permits the specifications of data where the individual data items of the same type or different attributes. So the most popular one is extensible markup language is widely used to represent semi-structured data. So here we have the details of the book, which contains the author details and then ISBN details and year of publication details. And for each author details, we have the last name and then username and the other author details, which includes the URLs. So next is network model. So network model is an extension of hierarchical model. It is used before relationship model. So here we have, for example, you consider a student entity which has more than one parent. So college and then department and library. And the department and library has the details of the particular student. So hierarchy model are generally used as semantic models in practice as many real world occurrences of events. So hierarchical model are also commonly called as physical models. For example, consider the student database hierarchical model. Here we have the course enroll and the students, and the courses can be assigned with one course can be assigned with one student, and the student can enroll for more number of courses. To summarize, so we have discussed about the data abstractions and both at physical level and logical level, and different views of data abstractions and instances at physical and logical and schemas, and different data models like ER model, relationship model, hierarchical model, object-oriented model, network model. Thank you.